In this video, we will explore graphing sine and cosine functions using key points. Let us start with the basic sine function and identifying its basic properties. So in finding the domain of this sine function, the domain is all real numbers or from negative infinity to positive infinity. And the range is from -1 up to +1. And its symmetry is with respect to the origin, so it is an add function. And the period of this sine function is the length of one complete cycle. So to identify the length of one complete cycle, so the period is 2 pi, and this period from 0 to 2 pi, it will repeat on the right side or after 2 pi and on the left side of the origin. So like that, and this one. So you can see that the period in this red graph, 0 to 2 pi, is repeated from 2 pi to 4 pi and so on, or -2 pi to 0, and so on up to negative infinity. And then to identify the x-intercepts, so they are -pi, 0, pi, 2 pi, and so on. And for the y-intercept, it is in the origin, which is y equal to 0. Then the maximum value of the sine function, so from negative infinity to positive infinity, the maximum value is 1, and this occurs when x is equal to pi over 2, 5 pi over 2, and so on. And while the minimum value is -1, which occurs at -pi over 2, 3 pi over 2, and so on. And for the basic cosine function, so let us identify also its properties. So the domain is also the same, which is all real numbers from negative infinity to positive infinity. And its range is from -1 up to 1. And the symmetry is with respect to the y-axis. So this cosine function is an even function, while the sine function is an add function. And to identify the length of one complete cycle, so we can identify that as 2 pi. So the length of one complete cycle of cosine is 2 pi. And after 2 pi, it repeats the same curve from 2 pi to 4 pi and so on. And also, it will repeat on the left side. And then for the x-intercepts, so we have -pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and so on. And then for the y-intercept, it is 1. And its maximum value is +1 and occurs at x equal to 0, 2 pi, -2 pi, and so on. While the minimum value is -1 and it appears at -pi, pi, and so on. On the next slide, we will determine the amplitude, period, vertical shift, key points of sine and cosine functions. The graph shows one complete cycle for sine and one complete cycle for cosine. The general form of a sine function is y equal to a sine of bx plus d, while the cosine function is y equal to a times cosine bx plus d. A is the coefficient multiplied to sine of bx, while bx is the angle for sine, and d is a real number added to the sine function, same as this general form for cosine. Now to identify the amplitude is the height of the graph above or below the x-axis. So amplitude is determined by getting the absolute value of A. While the period is the length of one complete cycle on the x-axis. So the period for sine function is 2 pi, and the period also for the cosine function is 2 pi. But the period for the general form of a sine and cosine is identified by 2 pi over absolute value of b. So in this sine x, b is equal to 1, so it's 2 pi divided by 1. So that's why the period of sine and cosine is 2 pi. And then for the vertical shift is determined based from the value of d. So in the vertical shift, it is shifted d units upward if d value is positive, and it is shifted d units downward if the d value is a negative. And then for the key points, to identify the key points of a sine function, so you will follow the curve of a sine function, and the x values of the key points are determined by this formula. So you will start from 0 to period, and then you will divide into 4 intervals to get 1/4 of the period, 2/4 of the period, or 1/2 of the period, then 3/4 of the period, and then the period. So you will have the 5 x values of the key points. And then for the y values, it can be determined by this formula, which is d, a plus d, d, negative a plus d, and d. This formula can be identified from this sine wave. So we can discuss that later. And then for the cosine function, it will follow from this cosine wave. And the key points, the x values of the key points will be the same with the sine function, which is 0, 1/4 of the period, 2/4 or 1/2 of the period, 3/4 of the period, and the period. And then the y values will be a plus d, d, negative a plus d, d, and a plus d. The graph shows one complete cycle for sine and one complete cycle for cosine. The general form of a sine function is y equal to a sine of bx plus d, while the cosine function is y equal to a times cosine bx plus d. A is the coefficient multiplied to sine of bx, while bx is the angle for sine, and d is a real number added to the sine function, same as this general form for cosine. Now to identify the amplitude is the height of the graph above or below the x-axis. So amplitude is determined by getting the absolute value of A. While the period is the length of one complete cycle on the x-axis. So the period for sine function is 2 pi, and the period also for the cosine function is 2 pi. But the period for the general form of a sine and cosine is identified by 2 pi over absolute value of b. So in this sine x, b is equal to 1, so it's 2 pi divided by 1. So that's why the period of sine and cosine is 2 pi. And then for the vertical shift is determined based from the value of d. So in the vertical shift, it is shifted d units upward if d value is positive, and it is shifted d units downward if the d value is a negative. And then for the key points, to identify the key points of a sine function, so you will follow the curve of a sine function, and the x values of the key points are determined by this formula. So you will start from 0 to period, and then you will divide into 4 intervals to get 1/4 of the period, 2/4 of the period, or 1/2 of the period, then 3/4 of the period, and then the period. So you will have the 5 x values of the key points. And then for the y values, it can be determined by this formula, which is d, a plus d, d, negative a plus d, and d. This formula can be identified from this sine wave. So we can discuss that later. And then for the cosine function, it will follow from this cosine wave. And the key points, the x values of the key points will be the same with the sine function, which is 0, 1/4 of the period, 2/4 or 1/2 of the period, 3/4 of the period, and the period. And then the y values will be a plus d, d, negative a plus d, d, and a plus d. Now for this example, let us graph the function y equal to 2 sine of x over 2 plus 1 for its domain. X is from negative 2 pi to 4 pi using the key points. So first, it's better if we will identify the values of a, b, d so we can substitute appropriately in this properties. So comparing this function into this general form, the value of a is equal to 2 and b is equal to 1 half because x over 2 is the bx, so we just need the value of b, so it's 1 half, and then the value of d is equal to 1. And then the amplitude is determined by absolute value of a, so we will take the absolute value of 2, which is equal to 2. So that is the height of this graph. And then for the period, we will follow the formula 2 pi over absolute value of b, and then since b is equal to 1 half, so you will substitute 1 half in b, and then simplifying this, it will give you 4 pi. And then for the vertical shift, it is determined from the value of d, which is equal to 1. So it means it is shifted 1 unit up. And then let's now graph the sine function. So in graphing, we will be needing the period and the values of a and d for the key points. So let's start graphing. So let us start plotting 4 pi in the x-axis. So this is 4 pi. And then after that, we will divide the 0 to 4 pi into 4 equal parts. So let's start by getting the half. The half of 4 pi is 2 pi. And then getting the half of this, 0 to 2 pi. So you will get pi. And then the half of 2 pi to 4 pi is 3 pi. So you can see that the distance, the equal interval, is pi. 0, then added by pi, then pi added by pi again, it's 2 pi, added by pi again, it's 3 pi, added by pi again, it's 4 pi. So these are the 5 key points starting from 0, pi, 2 pi, 3 pi, and 4 pi. So these are the x values of the key points. So to get the y values of the key points, so let us put the intervals here in the y-axis. So the y values of the key points, we will start creating the sine wave. The sine wave or the sine function will follow like this. So the middle, so let us assume the middle is the x-axis. So it will give you d, d, and d. And then for the maximum points, the formula is a plus d, and the minimum point, the formula is negative a plus d. So the only difference is the sign of a. For the maximum, it's positive a. For the minimum, it's minus a. So this is the same. You will add d in a and minus a. So these are the y values of the key points. So if we will start solving for d, we know that d is equal to 1. And then the a plus d, if you will add a with the d, so it's 2 plus 1, which is equal to 3. And then for the negative a plus d, negative of 2 added by 1, it is equal to negative 1. So you would just follow that d is equal to 1 here. So it means to say, when the first angle is 0, the first y value is 1. So the point is 0, 1. So you will plot here. And then the second angle is pi. The second y value is 3. So it's pi 3. So plot pi 3. The third angle is 2 pi, and the y value is 1, so it's 2 pi, 1. And the next angle is 3 pi, where the y value is negative 1, so 3 pi, negative 1. And then the last angle is 4 pi, and the y value is 1, so it's 4 pi, 1. So here, you can connect these points using a smooth curve to draw the sine wave. So this is the graph of this sine function from 0 to period, which is 0 to 4 pi. But if you will look at the domain, so we are requiring to graph this sine function from negative 2 pi to 4 pi. So it means to say we are done graphing from 0 to 4 pi, so we need to graph on the left side, which is 0 to negative 2 pi. We can see that negative 2 pi to 0, it's only half of this period. So meaning, we will graph on the left side. So negative pi and negative 2 pi. And then, so we would just follow this graph. We will just copy this part on this side. So like that. So this is now the graph of this sine function from negative 2 pi to 4 pi. And take note, you have to check the endpoints. So the endpoint here is negative 2 pi, which is included, and 4 pi is also included here. So you should have a close point here and a close point there. So this is the graph. Now, to be able to find the range, we can easily find the range based from the graph, which is negative 1 up to 3. And you can also use the formula wherein the maximum is a plus d and the minimum is negative a plus d. So we can write that as negative a plus d, comma, a plus d, which is negative 1 to 3. Another way in getting the key points, once you identify the x values, the 5x values of the key points, so you can use calculator in getting the value of y, but make sure your calculator is in written mode, and then substitute these x values of the key points in the given function. For example, so your x values are 0, then pi, 2 pi, 3 pi, and 4 pi. So you will get all the x values here. And then to get the y values, so you will substitute 0 in the given function, then put in calculator, it will give you 1. Then next is pi, put again in the calculator, substituting pi in the x values here, and then you will get 3, and then 1, and then negative 1, and then 1. Now for the next example is graphing the function y equal to 2 cosine pi x minus 2, for x is from negative 2 up to 3, negative 2 included, but 3 is not included, using the key points. So let us start comparing this function into this general form. So a is equal to 2, then b is equal to pi, and d is equal to minus 2. To get the amplitude, so we will use the formula absolute value of a, which is absolute value of 2, which is equal to 2. And then for the period, we will be using the formula 2 pi over absolute value of b, then placing b as pi, so it's 2 pi over pi, and then canceling pi, it will give us 2 as the value of the period. And then for the vertical shift is the value of d, which is equal to a minus 2. It means it is shifted 2 units down. Now to graph the function, let us start by the period again. So we will plot or locate 2 in the x-axis. So the x-axis, the period is 2, and then we will divide this into 4 equal parts. The half of this is 1, and then getting the half of 0 to 1 is 1 half, and then getting the half of 1 to 2, so we will get 3 halves. So you can see that the distance of each interval is 1 half. 0 added by 1 half is 1 half. 1 half added by 1 half is 1. And then 1 added by 1 half is 3 halves. And 3 halves added by 1 half is 2. So these are the 5 key points including 0. Now, let us identify the y value of the key points. Y value of the key points can be identified by the cosine wave, since this function is a cosine. And the cosine wave is like a U shape, like this. And then let us start in the middle, assuming the x-axis is in this middle. So this is the value of d. And then the maximum points, the formula is a plus d. And then the minimum point is minus a plus d. And then let us identify the values of d first. The d is minus 2. So this is equal to minus 2, same as this. And then a plus d, we're adding a and d, which is 0. And then negative a plus d, the negative a plus d is you will get the negative of 2. So negative 2 added by negative 2, it will give us a negative 4. So the first y value is 0 for x equal to 0. So we will have 0, 0. So that's the first point. And then for the second point, when the x value is 1 half, the second y value is a minus 2. So 1 half minus 2. And then for the third point, the x value is 1. The third y value is negative 4. So it's 1, negative 4. And then next is the y value is negative 2 again. And next is the y value is 0, same as this. So these are the 5 key points for the cosine function. So do not connect this using straight line, but instead connect this using a curve, like that. And then, so after graphing the period, let's go back to the domain. We have to graph the cosine function from -2 up to 3. We have graphed the one complete cycle from 0 to 2. So we need to extend another 1 unit on the right side, which is half of this period. So we will plot or locate 3 and then divide this into 2. So what we're going to do is we are copying this function over here, but only half. So we're copying this left side, this one, copying it there. And we can see that when x is equal to 3, so this point is undefined or not included because 3 is not included in this domain. And then on the left side, we have from -2 up to 0. So -2 up to 0, so the period or the distance is also 2. So it looks like we have to copy the whole complete cycle on the left side of the origin or on the left side of 0. So let us plot -2 and then dividing again into 4 equal parts. So copy this green graph, this one, over there. And let's check again the endpoints. So -2 is included, so that's why we have to make a close point here. While 3 is not, we have to make this as an open point. And now lastly, so we can easily find the range. And as we said, the range here is the minimum is -4 up to 0, or -a plus t to a plus d. So that's the formula. And then substituting that, it's equal to -4 up to 0. For the next example is graphing the function y equal to -2 sine 2x minus 1, for x is from -pi to pi, where -pi and pi are not included. So here, we can see that the a value now is a negative, meaning there's a reflection. So let's compare this in the general form. So we can see that a is equal to -2, b is equal to 2, and d is equal to -1. So the amplitude again is absolute value of a, which is absolute value of -2, which is equal to 2. And then the period is 2 pi over absolute value of b, and substituting 2 in the b, so it's 2 pi over 2, which is equal to pi. Then the vertical shift is the value of d, which is a -1, so meaning it is shifted 1 unit down. And then, so let's start graphing the sine function. So we will start by the period again, which is pi. So locating pi on the x-axis, this is the pi. And then dividing this into 4 equal parts. So half of pi is pi over 2. And then from 0 to pi over 2, dividing this into half again. So we will get pi over 4. So we can see that the distance here is pi over 4. If I will add pi over 4 and pi over 4, you will get pi over 2. And if you will add pi over 4 and pi over 2, you will get 3 pi over 4. And verifying the last angle, if you will add pi over 4 in 3 pi over 4, you will get pi. So these are the 5 x values of the key points, including 0 here. So now let's plot the intervals for the y-axis, and then let us create a sine wave to get the y values of the key points. So this is the sine wave, and the middle again, the middle points are values of d, and then the maximum value is a plus d, and the minimum value is minus a plus d. And then getting the values of d, d is equal to -1, so we have -1, and a plus d is, we're just adding a with the d, which is equal to -3. And then the negative a plus d, you will get the negative of this will be +2 added by -1, it will be equal to +1. So now we can plot the points starting from 0. The first y value is -1, so 0 -1. The next angle is pi over 4. The y value is -3, so plot at -3. Next angle is pi over 2. The next y value is -1 again. And then the next angle is 3 pi over 4. The next y value is +1. And then the last angle is pi, where y value is equal to a -1. So we connect this using a smooth curve, no straight line. So this is the sine function. And then we can see that this is from 0 to pi. But in the domain, we have to graph this from negative pi to pi. So it means we have to extend this on the left side. We will copy one complete cycle because we need negative pi to 0. So let's locate negative pi, and then we will divide this into 4 equal parts. And then after that, copying these points or this one complete cycle on the left side. So we will have these 4 points, and copying this graph, you will get that. So now we need to make sure that on the endpoints, negative pi to pi are not included. So this should be open, and this is also open. And then for the range is the minimum is negative 3 up to 1. Or following the formula, since A is a negative, so meaning this maximum will be minimum and this minimum will be maximum. So it's from negative 3 up to 1. Now for the next example, we will graph the function negative 2 cosine of pi x over 2 for x from negative 2 up to 6 using the key points. So here, let us compare again in the general form, and then a is equal to minus 2, and then b is pi over 2, and d is equal to 0. So because there's no real number added to this cosine function. So the amplitude is the absolute value of a, which is absolute value of minus 2, which is 2. And the period is 2 pi over absolute value of b, since b is pi over 2. So this is equal to 4 because pi will cancel out. Then the vertical shift is the value of d, which is 0, so meaning there's no vertical shift. And then the range, we will identify that later. And then to be able to graph for this cosine function, let us start with the period, which is equal to 4. So locating 4 in the x-axis, so this is 4. And then dividing this into 4 equal parts, let's start getting the half, which is 2. And half of 0 to 2 is 1. And then half of 2 to 4 is 3. So these are the 5x values of the key points, including 0 here. So let us plot the intervals for the y. And then, so let's create the cosine wave. Cosine wave is like a U shape. And let's identify the formula here. So the middle is d, the maximum are a plus d, and then the minimum is negative a plus d. Then identify the value of d, which is 0. So the middle is 0. And then the a plus d is we're adding a with the d, which is negative 2 plus 0 is a minus 2. And then negative a plus d, we will get the negative of this minus 2, which is positive 2, adding to 0 is a positive 2. So let us now start plotting. The first angle is 0, and then the first y value is a minus 2. So we have a point 0 minus 2. And then the second angle is 1, the next y value is 0. So we will make a point at 0. And the next is 2, positive 2. So we have 2, 2. And the next angle is 3, 3, 0. And then 4, minus 2, 4 minus 2. And then connecting this using a smooth curve, no straight line. So this is the graph of the cosine function from 0 up to 4. And then going back to the domain, we need to plot from negative 2 to 6. So since we already plotted 0 to 4, we have to extend at 6. So 46 is 2 units, so meaning it's half of this period. So we will copy this part. So let's locate 6. So this is 6. And then we will copy this graph, making a point here at 5 and making an open point on the other. So that one. And I make a close point because the endpoint 6 here is included. And then copying this graph over there. And then on the left side, since this is negative 2 to 0, negative 2 to 0, the distance is 2, meaning half of this period again, half of this graph. So let us locate minus 2, and then copying this part, we will have this point and another point which is open. This is already the end point since negative 2 is not included, so you have to make an open point here. And then copying this part of the graph over there. So this is the graph of this function from negative 2 up to 6. So let's review again the endpoint. This is this negative 2 here is not included while 6 is included, so this is a closed point. And then lastly, we can find the range. So if you can see, the a is a negative, so meaning this maximum will be a minimum and this minimum will be the maximum. Because this minus 2 and 2, so meaning the range is from minus 2 to 2. If you will look at the graph, the minimum here is minus 2, the maximum is 2. So the range is from minus 2 to 2. And now to continue identifying the properties, so based from this graph, so we will find the x-intercepts. They are negative 1, positive 1, 3, and 5. So these are the x-intercepts. And there's only one y-intercept, which is minus 2. Then the maximum value is 2, appeared here and there. Even it's not appeared in this point, but still the maximum value is 2. And then the minimum value is a minus 2. For what values of x does f of x equal to 6? F of x equal to 6 is y equal to 6. It's horizontal line over here. And this horizontal line will never intersect this graph. So that's why this is none. And then for h, for what values of x is f of x greater than 0? Meaning we need the interval of x where the graph of the function is above the x-axis, not on the x-axis. It's only above the x-axis. So we will not include the x values on the x-axis. So the first one, this is above, over and here also, and this one. So meaning the x value, the x interval here is from negative 2 to negative 1, negative 2 to negative 1, both of them not included because we should not include this point, and this is also not included. So over here is from 1 to 3, so we will not include 1 and 3, that's why this is open. And another one is 5 to 6. The x value here is 5 to 6. So we will not include a 5, but we have to include 6 because when x is 6, the graph is above, or f of x is greater than 0. So that's for letter H. And then next is, for what values of x is the function increasing? It is increasing at this part, increasing here and over there. So the x value here is starting from 0 up to 2. 0 and 2 are included. And then another one is from 4 up to 6. 4 and 6 are included. So this is the x interval where the function is increasing. Now for the last part is sketching the graph of the absolute value of f of x. F of x is also equal to y. So if the y values are negative, negative meaning if we will get the absolute value, it will be positive. So it means to say, with respect to the graph, if there's a graph below the x-axis and I will get the absolute value of the graph of y here, all of them will be positive. So it means if the graph is below the x-axis like this, then it will be reflected on the x-axis. It will be positive. And then this graph here will be also reflected on the x-axis because it will be positive. So there will be no graph below the x-axis. It will be reflected over here. So the graph will be like this.